Hello everyone. The present lesson is Solutions Part 1. It is a notes for class 12th students. Please subscribe to my channel, comment and share my videos. Solutions. This is a lesson for class 12th students board examination as a revision. Part 1. Solution. A homogeneous mixture of two or more substances is called solution. A binary solution is that having two components. If the solution has two components, two substances, then it is a binary solution. There are different types of solutions. The example for binary solution is say salt solution, sugar solution, etc. The types of solution depending on the physical state of the solute and solvent. Gaseous solutions in which gas is the solute, solvent is the gas and solute is gas, liquid, solid. Similarly, in liquid solutions, liquid is the solvent and gas, liquid, solid are three different states of the solute. In solid solutions, solvent is the solid, gas, liquid and solid are the different states of the solute. For example, mixture of oxygen and nitrogen gases is the solution of gas-gas mixture. Chloroform mixed with nitrogen is the mixture of gas-solvent solution, and mixture of camphor in nitrogen gas is an example of a gas-solid solution. So, similarly, different types of solutions. A solution can be expressed its concentration in different methods. That is the methods of expressing concentration of a solution. Concentration means if the amount of solute present in a solution is known, then it is a concentration. The different methods of concentration are mass percentage, volume percentage, mass by volume percentage, mole fraction of any component of the mixture, that is solution, parts per million, molarity, molality, normality. So all these are the different methods of expressing concentration, that is the amount of solute present in a given solution. Now let us discuss all these methods one after the other. Mass percentage, W by W of any component is defined as the mass of the component in the total mixture of solution. So mass percentage equal to mass of the component in solution by total mass of the solution into 100. If 10 grams of sugar is dissolved in 90 grams of water, then it is a 10% solution. So taking the total amount of solution as 100, and if the amount of solute is say 10 grams or 20 grams, the remaining is a solvent. Volume percentage, V by V, of any compound is defined as the volume of the component present in the 100 ml of total solution. Therefore, volume percentage equal to volume of the component in the solution by total volume of the solution into 100. Similarly, just like in the above example, if 10 ml of ethanol is dissolved in 90 ml of water, it is 10% ethanol solution by volume. Now, mass by volume percentage. So, it is the mass of the solute present in 100 ml of solution. So, in this method, mass is taken in grams and volume of the solution is taken in 100 ml. This method is generally used in medicines and in pharmacy. Another method of expressing concentration is parts per million. When the solute present is in traces, that is very less amount, this method is used. Generally, air pollution is expressed in this method. So, parts per million, ppm equal to number of parts of component by total number of parts of solution into 10 to the power 6. Now, let us see this example. A sample of drinking water was found to be severely contaminated with chloroform. The formula of chloroform is CaCl3, supposed to be a carcinogen. Carcinogen means cancer causing. The level of the contamination was 15 ppm by mass. Express this in percentage by mass and determine the molarity of chloroform in the sample. So this is the solution for this problem, and this problem is in the textbook as in-text question. Total mass of the mixture, total mass of the mixture, let the mass of the solute, let the mass of the solute and solvent be, mass of the solute be WB and mass of the solvent is WA. So this is the WA plus WB is the total mass of the mixture. Here mass of the solute is 15 grams of CCl3, CHCl3. Mass of the solvent plus mass of the solute plus solvent is 10 to the power 6 grams. Mass percentage of the solute equal to mass of the solute by total mass into 100. That is 15 by 10 to the power 6 into 100. That is 1.5 into 10 to the power 4. Molar mass of the chloroform is 119.5 gram mole. So mass of the solvent equal to 10 to the power 6 minus 15 equal to 9,99,985 grams. So if it is expressed in terms of grams divided by 1000, therefore in kilograms, mass of the solvent in kilograms equal to 999.99 kilograms. Now molarity equal to mass of the solute by molar mass of the solute into mass of the solvent in kilograms. This is the molality. So mass of the solute is 15 by 919.5 into 119.5, that is molar mass of the chloroform. 119.5 into 999.99 kilograms. So if it is simplified, we get 1.25 into 10 to the power minus 4 mole per kilogram. That is the molality of the chloroform in water. Now let us see the another method of expressing concentration is mole fraction. Mole fraction equal to number of moles of the component by total number of all the components in the mixture. That is XB. XB means it is the solute in less quantities. So therefore mole fraction of solute XB equal to NB by NA plus NB. Number of moles of, therefore number of moles of any substance equal to, we can find the number of moles of the substance is equal to given mass by molar mass of that substance. Now based on this, let us do a small problem. Calculate the mole fraction of the benzene in solution containing 30% by mass in carbon tetrachloride. So this is also textbook NCERT textbook question. So 30% of benzene means 30 grams of benzene is present in 70 grams of carbon tetrachloride. The formula of carbon tetrachloride is CCl4. Molar mass of benzene C6H6 is 78. Now molar mass of benzene is 78. Number of moles of benzene equal to given mass by molar mass. That is 30 by 78 is equal to 5 by 13. If we simplify, we get 0.230. Similarly, molar mass of carbon tetrachloride is CCl4 is 177.5. Number of moles of solute equal to given mass by molar mass. See, in 30% benzene, 30 grams is benzene and remaining 70 grams is CCl4. So given mass by molar mass 70 by 177.5, that equal to 0.395 mole. Now the total number of moles of both the components of benzene and carbon tetrachloride is 0.230 plus 0.394 is equal to 0.624. The total number of moles is 0.624. Now mole fraction of benzene equal to number of moles of benzene by total number of moles. That is 0.230 by 0.624 is equal to 0.36. So how do we find the mole fraction of carbon tetrachloride? In any solution, the mole fraction of sum of the mole fractions of all the components in a mixture is 1. Therefore here two components are there, one is benzene and one is CCl4. So 1 minus mole fraction of benzene, you will get mole fraction of CCl4. Now let us discuss the another method of expressing the concentration, that is molarity. Molarity is the number of moles of solute present in 1 liter of solution. So molarity is denoted by the capital M is equal to number of moles of solute by volume of solution in liters. So this is number of moles of solute is found by given mass of the solute by molar mass divided by volume of the solution. It is understood that in most of the cases volume of the solution is given in milliliters. Therefore, this is to be converted into liters. Volume of solution in milliliters by 1000 because 1 liter equal to 1000 ml. This is nothing but given mass by molar mass into 1000 by VML, or at the end the formula is W by M into 1000 by VML. This is the formula of molarity. Another method of expressing the concentration is molality. Molality is denoted by the small m. Molality is the number of moles of solute present in 1 kilogram of solvent. So molality m equal to number of moles of solute by mass of the solvent in kilograms. This is nothing but given mass of solute by molar mass of the solute divided by mass of the solute in grams, solvent in grams. So if the mass of the solvent is given in grams, then it is to be converted into kilograms by dividing by 1000. Therefore, given mass of solute by molar mass of solute divided by mass of solvent in grams by 1000 grams. So given mass of solute by molar mass of solute into 1000 by g grams, this is nothing but W by M into 1000 by g grams. Now let us find the equivalent weight of an element. So this is required for understanding the another method of concentration, that is normality. So equivalent weight of an element is the ratio of mass of the element to its valency. So equivalent weight of sodium equal to molar mass of sodium is 23 and its valency is 1. Therefore 23 by 1 is 23. Similarly, equivalent weight of magnesium is 24 by 2. Mass of magnesium is 24 and its valence is 2. 24 by 2 is 12. Equivalent weight of aluminum equal to 27 by 3, that is 9. Now, equivalent weight of the substance expressed in terms of grams. If equivalent weight is expressed in terms of grams, it is called gram equivalent weight. Thus, the gram equivalent weight of sodium is 23 grams, gram equivalent weight of magnesium is 12 grams, and gram equivalent weight of aluminum is 9 grams. So, it is written here. Basicity of an acid. Basicity means it is the number of replaceable hydrogen atoms in one molecule of an acid. The number of hydrogen atoms present in number of replaceable hydrogen atoms present in one molecule of an acid is known as basicity. Thus, HCl, HCN, hydrogen chloride, hydrogen cyanide, nitric acid, nitrous acid, etc. They are monobasic acids. Monobasic acids means they have only one replaceable H plus ions. It is known that when HCl is dissolved in water, it gives H plus and Cl minus. That means one hydrogen ion is replaced. Therefore, they are referred as monobasic acids. Sulfuric acid H2SO4, sulfurous acid H2SO3, carbonic acid H2CO3 are dibasic acids. They have two replaceable hydrogen atoms. And H3PO4, phosphoric acid, is tribasic acid. Acidity of a base. Here we discussed the basicity of an acid. Now we discuss the acidity of a base. Acidity of a base is the number of replaceable hydroxide ions in one molecule of a base. NaOH, KOH and NH4OH. These are monoacidic, and CaOH twice and BaOH twice are dibasic acids. They are dibasic. Equivalent weight of an acid is the ratio of the molar mass to its basicity. Just now we discussed the basicity, and if we take the ratio of molar mass to its basicity, it is nothing but equivalent weight of an acid. So equivalent weight of an acid is molar mass by basicity. So if the equivalent weight is expressed in terms of grams, it is nothing but gram equivalent weight, as we discussed just now. So gram equivalent weight of HCl equal to 36.5 by 1 equal to 36.5 grams. Gram equivalent weight of sulfuric acid is 98 by 2, that is 49 grams. Gram equivalent weight of phosphoric acid H3PO4 is 98. Its molar mass is 98 and its basicity is 3. Since it has 3 replaceable hydrogen atoms, it is 22.66, that is approximately 23. Equivalent weight of a base is the ratio of molar mass to its acidity. Acidity means number of replaceable hydroxyl ions. So equivalent weight of base equal to molar mass by acidity. Therefore, gram equivalent weight of sodium hydroxide is 40 by 1. It has only one hydroxide ion. So 40 by 1 it is 40 grams. Gram equivalent weight of barium hydroxide is its molar mass is 171 and its basicity acidity is 2. Therefore, it is 85.5 grams. And gram equivalent weight of calcium hydroxide is 37 grams. Now let us discuss the normality. Normality is the number of gram equivalent weights present in 1 liter of solution. So normality equal to number of gram equivalent weights by mass of the solvent in kilograms. So number of gram equivalent weights, how do you find? Given mass of the solute by equivalent mass of the solute divided by volume of the solution in milliliters by 1000. So given mass of the solute is solute by equivalent mass of solute into 1000 by VML. It is nothing but W by E into 1000 by VML. If a concentrated solution is to be diluted to certain volume, how much water is to be added to it? To find this, we have a formula, that is dilution formula is equal to M1V1 is equal to M2V2. M1 and V1 are the molarity and volume of the concentrated solution, and M2 and V2 are the molarity and volume of diluted solution. If the percentage composition and density are given, then molarity can be found by using the following formula, that is molarity equal to percentage composition into density into 10 by molar mass. So by using density and percentage composition, we can find the molarity directly. In the same manner, if two solutions of same solute with different concentrations are mixed, then the concentration of the mixture is given as molarity equal to M1V1 plus M2V2 by V1 plus V2. That is the molarity of the mixture solution is found by this formula. Now let us do a problem. How many milliliters of 0.1 m HCl are required to react completely with 1 gram of mixture of sodium carbonate and sodium bicarbonate containing equimolar amounts of both? Now this is the NCERT textbook question. Now let us do the solution here. Molar mass of sodium carbonate is 106, and in 1 gram of mixture, let the mass of sodium carbonate be X. Therefore, number of moles of sodium carbonate is X by 106, and molar mass of NaHCO3 is 84. As mass of sodium carbonate is X, then mass of NaHCO3, sodium bicarbonate, is 1 minus X. Then number of moles of NaHCO3 is 1 minus X by 84. Then reaction between sodium carbonate and HCl is, that is 1 mole of sodium carbonate needs 2 moles of HCl. X moles of X by 106 moles of Na2CO3 needs 2X by 106 mole of HCl. Then reaction between sodium bicarbonate and HCl is NaHCO3 plus HCl gives NaCl plus H2O plus CO2. See, in this equation, 1 mole of bicarbonate needs 1 mole of HCl. Therefore, 1 minus X by 84 mole of HCl needs 1 minus X by 84 mole of hydrochloric acid. Now the continuation of the solution. Since the mixture has equimolar of sodium carbonate and sodium bicarbonate, X by 106 equal to 1 minus X by 84. This implies 84X equal to 106 minus 106X. Therefore, 190X equal to 106 and X equal to 106 by 190, that is 0.56. The mixture needs sodium carbonate, the mixture needs X by 106 and 1 minus X by 84 moles of HCl. Here this, so X by 106 plus 1 minus X by 84 is equal to 0.56 by 106, 1 minus 0.56 by 84. So this is nothing but 0.0053. Because it is equimolar, number of moles of sodium carbonate and sodium bicarbonate are same. Therefore, 0.0053 plus 0.0053 is nothing but 0.0156. This is the number of moles of HCl required. Now, volume of the HCl required is required to be V. Therefore, V into molarity of the HCl given as 0.1 molar. So 0.1 is equal to 0.0156. Therefore, volume is equal to 0.0156 by 0.1. This is nothing but 0.156 liter or 156 milliliter. Now let us do another problem. The solution, a solution is prepared from, this is the antifreeze solution. An antifreeze solution is prepared from 222.6 gram of ethylene glycol. The formula of ethylene glycol is C2H6O2 and 200 gram of water. Calculate the molarity of the solution. If the density of the solution is 1.072 gram per milliliter, then what shall be the molality of the solution? Here solute is ethylene glycol and molar mass of ethylene glycol is 62 gram per mole. Number of moles of glycol is equal to mass of the ethylene glycol by molar mass. So 222.6 by 62 is nothing but 3.59 moles. Mass of water is 200 grams. If 200 grams is converted into kilograms, this becomes a 0.2 kilogram. Total mass of the mixture is equal to ethylene, mass of ethylene glycol plus mass of water, which is nothing but 222.6 plus 200 is equal to 422.6 grams. This is the total mass of the mixture. Density of the mixture in the is given in the problem as 1.072 gram per milliliter. Volume of the solution is obtained by dividing mass by density. Therefore, 422.6 by 1.072, it is nothing but 394.22 milliliter. Molarity is found by using the formula weight of the given solute by molar, its molar mass by 1000 by VML. This is nothing but 222.62 into 1000 by 394.22. So this 394.22 is the volume of the solution, 222.6 is the mass of the solute, 62 is its molar mass. Therefore, if it is simplified, we get 9.106 mole per liter. That is, molarity of the solution is 9.106 mole per liter. Molality is equal to number of moles of solute by volume of solvent in kilograms. That is, number of moles of solute is 3.59 by volume, mass of the solution in kilograms is 0.2. Therefore, it is nothing but 17.95 mole per kilogram. Now, let us see the relation between molarity and molality. Let the number of moles of solute be N, volume of the solution in milliliters be V, and mass of the solvent in grams be G grams. So, molarity M is equal to number of moles of solute into 1000 by VML. Actually, the formula here is number of moles of solute by volume of solution in liters. Therefore, if it is reversed, we get in this manner. So, by rearranging this, we multiply with 1000 by G and divide with 1000 by G. So, it is in this manner. So, let us rearrange this. N into 1000 by G grams, here this middle term is written here, into 1000 by VML into G by 1000. This is nothing but N into 1000 by G grams is nothing but molality. Therefore, it is molality into G grams of solvent by, here 1000 cancelled, and this is VML of the solution. Therefore, molarity, now finally we derived this relation between molarity and molality. Molarity into VML of solution is equal to molality into G grams of solvent.